Hello and welcome. My name is Partho Majumdar. In this course, we are learning how machines learn. So we start our discussion with how machines create regression models. We will take a simple regression model, that is a linear regression model, to understand the concept, and the concept will be applicable for any other type of regression models that machines learn. Before we go on to the discussion on linear regression models, just let's remind ourselves that machines can basically perform supervised learning and unsupervised learning. And in supervised learning, the machines can perform regression models and classification models. That is, machine can solve regression problems and classification problems. Now, regression problems are the problems in which the machine solves problems in which the target variable or the dependent variable is a continuous variable. So here we are. This is what we will be discussing. So our points are that this is a supervised learning model. Supervised learning model basically means that we will provide data to the machine based on which the machine will create an algorithm for itself and use that algorithm for making predictions. That is supervised learning. And regression problem basically means that we will have something like this: y is equal to some function of x, where x is the independent variable, independent variable, and y is the dependent variable. So this is what the machine will try to predict for us based on the values of x what we will give to the machine. Okay, so let's get started. We will first use Excel, in which we will see the mechanics, and then we will go on to Python, where we will see how a real problem of regression is solved. So here we are in Excel. Our problem is that we will try to find the third side of a right angle triangle, given that we have two other sides information. Now what we have done is that we have run an experiment. It is very simple. On a piece of paper, draw a right angle triangle, then measure the two sides. Measure the two sides, which is the altitude and the base. So the altitude, let's call it A, side A, and the base, let's call it B, side B. And also measure the hypotenuse, that is the side C. So this is the information what you can get by doing a simple experiment. Now, this is our input data. Using this input data, we will ask the machine to learn how to calculate the side of a right angle triangle given the base and altitude is given. Then he will calculate the hypotenuse. So now this is the input data what we will provide. That is the side A, side B, and side C. Now we will form a linear regression model. So the model will look like this, where we will have y is equal to b0 plus b1 into x1. x1 is the side A, plus b2 into x2, where x2 is the side B. And y will be the prediction what we will make. So y is the side C. So we will try to calculate, we'll ask the machine to calculate the side C given A and B is provided. So what we will do is that the machine we will have to compute the values b0, b1, b2, because x1, x2 we have and y it has to calculate. So b0, b1, b2 the machine has to calculate. So these are the three values what the machine has to calculate and understand how to create the model. So what we will do is that we will give it a initial value. Let's say we give a value of 3, 3, 3. 3 for b0, 3 for b1, and 3 for b2. And we will tell the machine, use these values and try to see what is the value of y you get. Now the predicted value of y, we will call it y hat. So according to this formula, y hat should be equal to b0. So this is, we will fix it, b0 plus b1, we will fix this also, into x1, that is this one, plus b2, we will fix this, into x2, that is side B. So this is the value of y hat. So we can copy this value across the other data points. So this is what we get. So now this is the predicted value of y given that a and b sides are given according to the formula what machine has created. Now what the machine will do is that it will try to find out what is the error in its calculation. Now we have given him the actual values of y. So against the actual values, it will find out how well did it do. So the error is nothing but y minus y hat. That is this one. So here he is getting an error. So we will compute all the errors. Next, what the machine will do is that we will create the square of errors. So this raised to the power 2. So it creates the square of the errors and finds the square of all the errors. Now that we have the square of errors, we can find the mean square error. Mean square error is nothing but average of all the square errors. So he gets a mean square error. Now the machine thinks is that the mean square error is quite large. I need to reduce it. So how does it reduce it? Normally in machine learning, we will use techniques like gradient descent. However, for understanding how the machine does the work, let us use linear programming. So in linear programming, what we will do is that we will say that these are our variables which the machine has to alter, and this is the value. This is the value which the machine has to minimize. So this is the value which the machine has to minimize. So let us set up the linear programming problem now. So we go to data, we go to solver, and we say that this is the variable which you have to minimize by changing the variables, these three. So by changing these three variables, you have to minimize the mean square error. And we have no other constraints at this point of time. So let us see how it can solve it. So now the machine is solving the problem. So what did it get? Let us see the solution. It's got some solution, and the mean square error has been reduced quite a bit. So it has got some solution. Let us see how good the solution is. So you see here, more or less, he is getting the values pretty close to what the actual values were. Now let us test this model. So let us test this model. So we have to find the new y hat given our test data where a is 3 and b is 4. So now to find y hat, we can apply the formula, that is b0 plus b1 into x1, that is a, plus b2 into b, or x2. So now the machine is predicting 5.39. Now this is pretty good, but however we know that by Pythagoras theorem, we can calculate the third side by taking a square and b square and summing it up, and then finding the square root. So the actual value should have been 5, but the machine has predicted 5.39. Now the data scientist thinks that this is good, but I have a hunch that maybe the relationship is a square plus b square is equal to c square. So he sets up another problem in which he makes a linear regression model where he tries to find a relation between a square, b square and c square. So he makes x1 is equal to a square. So this is nothing but a square, and this is nothing but b square. So he sets up these values, and he again sets up, it has to be the same formula, y is equal to b0 plus b1, x1, b2, x2. But here x1 is a square and x2 is b square. So again he gives some initial values to the machine. Let's give the same values, 3, 3, 3 for b0, b1, b2. and find the new y hat. So here y hat is equal to this b0 plus b1 into x1 plus b2 into x2. So now let us copy this formula to the remaining data points also. So now we have got the predicted values of y. Given that we are finding relationship between a square plus b square plus c square. As usual, again let us try to figure out the error. So before we can find the error, we need to do one thing, that is we need to find c square. So I will introduce one more column here, insert a column here. So this is this is y is equal to c square. So let us find out c square. C square is nothing but this raised to the power 2. So now let us copy this across. So we have got c square also. Okay. Now we find the error between y and y hat, that is this minus this. Let us copy this across. So we got all the error terms. As before, we find the square of the error, that is this raised to the power 2. So we find the square of the errors. Okay, we've got the square of the errors, and we find the mean square error, that is the average of all these errors. We got that also. Now again, as usual, we will use the linear programming method to find the most optimal solution. So these will be our variables this time, and this will be the function that we will minimize. So let's go ahead and set up the linear programming problem. We go to solver and we change this. This is now going to minimize this value. Minimize by changing the cells. Let's change this to these values, and we have no other constraints. So let's solve it now. It's got some value, so it's got this formula. It says b0 is equal to 0, b1 is equal to 0.995, and b2 is equal to 0.999. This is pretty close to 0, 1, 1. So it is pretty close to getting a equation which is a square plus b square is equal to c square. Let us test this formula. So here we have the test data. A is 3, b is 4. So a square is 9 and b square is 16. So here c square that we will predict is equal to b0 plus b1 into x1 plus b2 into x2. So we got some data. This is c square, mind you. So we have to find c by taking a square root of this number. So we get 4.995, which is pretty close to 5. So you see how linear regression works and how machines learn to do linear regression.